Hello, Professor. This is Group 6 problem solving video. The first one is a backtracking problem. We're gonna do the primary numbers after the primary P with a summary S. So the first one is explain the problem. We're gonna use the approach to produce all the primaries less than S and greater than P, and then backtracking to find if such n primaries exist whose summary equal to the S. So we're gonna have three input numbers which are sum S, primary P, and M. And we need to find all n primary numbers after the primary P, whose the total amount of the n primary numbers which equal to the summary S. So the next part is the pseudocode. In the pseudocode, we have to create two arrays, which is set and prime, and create a method is prime to get the input x to check is a primary number or not, and create a method display. Display function is used to display the n primes whose sum equal to s, and create the method called primary sum, and used to evaluate all the possible n primes who the sum equal to s, and the method all prime is used to generate all primes. And then the method is prime. We use the math square root to check the x is a prime number or not, and use a condition to display the result, and use backtracking in the primary sum to find which n prime sum equal to the summary S. And then we're gonna move to the algorithm goes with an instance. So we have an instance S equal to the 41, N equal to the 3, and P equal to the 3. So the first one in the method all prime to get the input from the main. Now the variable have value n equal to 3, s equal to the 41, and p equal to 3, and the I is equal to the 4. And you go to the method is prime to get the input and convert by using the math square root to get value, and x equal to the 4 and the square root is equal to 2. And then we move to the all prime to check the method is prime that true or false. And for loop, the method is prime again to check the prime number. And then check condition in method all prime if the prime size is less than n, and then go to the method prime sum until the variable I less than or equal to the s. And the method prime sum get input all variable in beginning with the total is equal to 0, and n equal to the 3, and s equal to the 41, and the index equal to 0. And then we count the variable total and the index of the array set and check condition. The total is equal to the s and the size equal to the n, and the total is more than s or the index is equal to the primary size, or the size is more than or equal to them, and until the method go to the display to display the result. And we get the length of array list of set length equal to 3, so that means the n is equal to 3. And the length is equal to 3, so we're gonna display the result, and this is the output. And then the next part is implement the code to solve the algorithm. So let's move to the code. As you can see that we have two arrays and prime and the prime method to check the input x is prime number or not, and use display to display the all result, and primary sum method to use backtracking to find the unprimes which sum equal to the s, and then all primes generate all the primary numbers, and the main method to drive the code. So let's gonna run it. So we get this output 5, 7, and 29, which sum is equal to the 41. And this one also equal to 41, 41, 41, and 41. And their length also equal to the n, which is equal to the 3. So this is our problem 1, backtracking problems. Thank you for listening.